Now it doesn't.
That looks like a right triangle.
Okay.
It looks kind of.
In any type of triangle, we know these things right here. If I have a line here, okay, I could be given different pieces of information and figure things out. If I am told that these two lines are parallel and these two segments are equal, what can you conclude?
The top line's half the bottom line.
Yes, that is true.
The other two sides are equal.
That the measure of this is exactly half the measure of this, and that's what I was looking for, that these other two segments are also equal. Because we had a theorem that said that a segment joining the midpoint of one side of a triangle and parallel to another side is joined to the midpoint of the third side. So I could have been given the red information to start off with, and I could jump to those two conclusions. We also know that this line is parallel to this third side, and it's half of the third side. So all of those information, all those things go together. Now suppose I was given something different, but it's still all of this that goes together. Suppose this is what I started out with.
You can conclude that those two lines are parallel.
They be parallel.
I know that these are parallel. I know that this is half the measure of this. What else do we know? We haven't touched on it, but it's dealing with the angles.
The angles are.
Those are congruent, and also that one's congruent to that one
Because the corresponding angle.
It's not an isosceles triangle.
But then also the angles are supplementary with the other angles because they're.
Very good. Okay? But this is all the information that we have. So you need to know this. Because I could have questions such as, you know, this is equal to 2x plus 5, and this is equal to
And that
4x.
triangle is exactly half the big triangle.
Okay? And how would you know? Well, what is the relationship between those two sides? They're equal. So I could say, what's x? Or I could say, how long is this? Or I could say, how long is this? Okay? So there's many questions I can ask you, but it all starts from knowing these relationships. You've got to know them.
X equals 2.
Okay, and then we talked about our special parallelograms. The first one we talked about was a rectangle. Let's review everything we know. We'll draw the picture and we'll write it out.
Four equal angles.
Because it's like a wreck and the cars got tangled up.
Oh my goodness.
No, I'm pretty sure it's got something to do with angles.
Shh.
Full rect means no, it doesn't mean 4.
It's bottom.
We know that there are 4 right angles. What do we know about the diagonals of a rectangle?
They're perpendicular.
Bisect.
They do bisect each other, and they are congruent to each other.
They're perpendicular.
The rectangle's a parallelogram.
Yes, it is a parallelogram.
So could we just say that instead of having to write out all the stuff in parallelograms now?
Okay. So, but what that means is that if AC, if the length of AC is equal to the length of DB, and both of them are cut in half, then all of those halves are equal to each other. Okay? And now, haven't I just created 4 isosceles triangles?
Yes.
So in those isosceles triangles, this angle is equal to this one,
Which is equal to this one and that one.
which
and that
is
one
equal
and
to
that
this,
one. Vice versa.
and these equal, and these equal.
Why aren't they all? And the vertical angles.
No.
They aren't all equal
Why?
because the box is longer than it is tall.
Yeah. This is true.
And when you go from one angle to one corner to the other, you're not going at a straight 45. Okay, the only way you can go at a straight 45 is if the height and the length
It's
are
a
the
square.
exact same. Exactly. If it's a square.
Or a rhombus.
Okay, no. All right, we also learned about the rhombus. Be able to identify the properties of a rhombus.
All the sides are equal.
All the sides are equal.
So it's like a slanted square.
Exactly. Now all the angles are not equal though. Opposite angles are equal.
An unequiangular slanted square.
Okay, so we've got all equal sides. Opposite angles are equal.
Diagonals are perpendicular bisectors.
And the diagonals are perpendicular bisectors of each other. Now the diagonals don't equal each other. So it's not 4 equal segments there. It's 2 pairs of equal segments that have been created. And then don't forget, this is a parallelogram, so you've got all your stuff about alternate interior angles and corresponding angles and all that other stuff. All right? Oh, the diagonals do something else.
Perpendicular.
They, yeah.
We already said that. The diagonals bisect the angles. That they are drawn from. Okay? Remember, in a rectangle, it wasn't bisecting the angles. But in a rhombus, they are bisecting those angles. So not only does this big angle equal this big angle,
But the two little ones equal.
the two little ones are equal to each other also. Okay?
Wait,
Like
what?
rhombuses.
All right. Next, we talked about squares.
Very deep.
Water.
What do we have?
Four equal sides, 4 equal angulars, parallel
It's a
lines
rectangle, parallelogram, and a rhombus.
Exactly.
together.
In a triangle.
No, it's four triangles.
It's not a triangle.
2 triangles.
Or two triangles. Or 8 triangles.
4 congruent
Give or
sides,
take a couple angles.
4 90-degree angles. The diagonals are,
Perpendicular bisecting.
they are congruent. They are perpendicular bisectors. They bisect the angles. That's about it.
Lines are parallel.
Well, yeah, but it's a parallelogram. We don't have to say that. These are equal. These are all 45 degrees. Because if it's 4 90-degree angles and they're all being bisected, then it's a bunch of little 45-degree angles. And since the diagonals were equal to each other and they bisect each other, these 4 segments are congruent to each other.
Square is like everything's equal.
And all these
Squares are awesome.
are 90 degrees.
Squares
Now, so when you see this picture, you need to make all these little markings. Because here's where I'm going to throw in, okay, if this is 2x plus 5